Good afternoon, friends, to whichever part of the globe you belong to. I am Professor Dinesh Gusai, welcoming you on this module on operation management. I hope you have gone through our earlier modules and lectures that we had. So I hope that was value add to you, and you had made some notes out of it. That's most important, because we always have been mentioning right upfront that one of the learning strategies that really helps is writing, because a lot of time when we read a lot, we don't tend to recollect so many things. And the old saying goes that 10 times reading is as equivalent to 1 time writing. So writing has their own advantage about it. So I'm sure you have made notes about it, and I'm also, as you're listening to this lecture from wherever you are carrying a notebook and a pen. You're as comfortable as possible so that we optimize our learning well. Otherwise, if conditions are not really well, then the quality of learning gets compromised. So with this premise and this backdrop, as we always do, we start with what we have done from the past. We'll look into what's the broader overview, what's going up front, what's there for today, and third part we'll detail it out the today's session. So we have mentioned that when we are speaking of operation management, primarily we'll speak of 5 things, and those 5 things are: number 1, the outlook and the overlook of what operation management means. We have defined what was operation management, the importance, the need about it, and how it impacts. We have also spoken about 4 things when we are looking at operation management. We have also defined that it includes a span between moving from point A to point B. That means from inputting to outputting, from raw materials to finished goods. Whatever we can alter in this process constitutes operation management. We also spoken about 4 things that get influenced. Those are cost, quality, convenience, time. Those are the 4 parameters through which, or the gateways through which we optimize through operation management, these 4 parameters. And we also spoken that first part about understanding if you want to influence these 4 variables, we need to look into how value addition could be made up in each of these 4 gateways of cost, quality, convenience, time. Second module was on operation processes and few matrices that we dealt with, and few of the matrices that we dealt was the break-even point, which is an important element when we look into the basic processes within the operation management. We also spoke about just-in-time approaches, the lean management, the lean management. We also spoke a bit about Kanban as well when it comes to processes. The third part, which we had also covered in our third session of our module on operation management, was on PPC, that is production, planning, control. And we spoke about each of this. We have defined each of these elements in terms of primarily from a production parameter, and also looked into how production could be planned well, controlled well as well. This is what we have done in our earlier 3 modules. The 2 that are left out, that is the 5 of those operations. We always mention that operation management will discuss in the 5 heads. These are 3. 2 that we are going to still to address. 1 today would be on inventory management and how to really plan well and control inventories. And we look it through some models. This is what we will be addressing today. And the 5th part, which we will be addressing in our forthcoming modules, would be on supply chain management. In fact, let me tell you, today's session on inventory management is actually an offshoot of supply chain management. So let me give a preview of today's session, the broad overlook. So if you're looking at inventory management, what we'll do, we'll first define what does inventory mean. We'll define the importance, how inventories are going to impact What? The four gateways: cost, quality, convenience, time. Let me also tell you, today's session would be more graphical in representation. In fact, 70-80% of our slides are more graphical in nature. So they're more visual. So people out there who are listening to this module who are more visual learners will find this interesting, because that's their primary mode of learning. So a lot of graphical representation, few calculus, and you'll also have arithmetics coming in as well. But we would be primarily interested more from the mathematical equation, the inferences or the conclusions that we draw from that. That would be of prime importance for us. So today's module will address about defining inventory management, their impact and role, and we'll look into a few models as well. What are the few models that helps us to really make an impact through inventory management? When we speak about cost, quality, convenience, time, the four gateways that influences operation management, when we speak of inventory management or inventory planning and control, it primarily influences cost. Now, cost is one of the prime variable. It's also a value add when it comes to the end customer. So cost is one variable, and the second is service. It really redefines customer service when we are speaking of inventory management, and hence planning and controlling inventory becomes important. So let's get into the module of inventory planning and control. So let's define then what is inventory. Now, inventory is the raw material, component parts, work in process, or finished products that are held at a location in a supply chain. Now, I repeat, any inventory can be defined as raw materials, component parts, work in progress, finished products which are there held at a location in the entire supply chain value. Now, important to understand when we speak of inventory, friends, is that inventory is at various nodal points of a supply chain. What is supply chain? Supply chain is a point right from the goods are manufactured till the point the customer buys it. Entire value chain in this is called supply chain. So wherever stocks are lying, either at the company's end itself, to either at the distributor end, or could be a warehousing end, either it could be at a super stockist or possibly a retailer. So every stock held at various junctures is called inventory. Now, friends, also important to notice, inventory is not just the finished product. Now, in this example, I spoke about finished product, but it could be also raw materials. Now, raw materials to prepare the finished product could be partially products, it could be work in progress, it could be component parts, it could be any of those. So any parameter that we define for inventory, right from raw materials, component parts, even a work in progress or finished good, any of these elements that is held at a different point in a supply chain constitutes inventory. Now, the whole question is, why do you want to focus on this? How does it impact? Now we will look into the why about it. Now, have you understood the what about it? So anything that you want to understand, one of the good learning tools that you can apply it anywhere else also is as a learning strategies, the W's and the H question. So we start with the first W, that is what. So that's what is about definition. So we define what is inventory. After this what, we have to immediately come to the next W, and that is why. What does why gives? Importance, significance, impact, purpose. This is what why gives, isn't it? So whatever you do, even as a new thing to learn, you just first discuss, okay, what does this mean? Why are we studying this? Once we know this what and why, then we can get into where, when, whom, and one H. That's how. So we have got to the first W, that is what. We look into the why element in a couple of slides. Why do we care? And at a macro level, what does macro level mean? Macro level means the overview at a very gross level. At a very gross level, inventory is one of the biggest corporate asset. Now, tell me, any stock that is lying at any place, be it at the company end, the distributor, super stockist, retailer, is that cost? Yes, big time. Is it cost for the company? Yes. And hence, anything that we can use to optimize this inventories is beneficial. Now, there's a catch to it. Now, the catch is, when we spoke what is inventory, why can't we keep the inventory at the barest minimum? So, can we work on a zero inventory? That means once the customer places an order, then only we start manufacturing. Does that help? Not really, isn't it? Because the customer might not wait. That impacts customer service. That tarnishes the brand image. He might go to some other brand if the product is not available at the retailer, isn't it? We all do that. So, zero inventory doesn't help. Neither what helps is the high inventory, where you have loaded tons of stock available with you. So, the entire catch and the challenge when it comes to inventory, which is part of planning, is how do we optimize it? How do we see what all factors contribute to optimization? So, that's the cost involved. And investment, let's look into some values which are some staggering values. And if you see investment in inventory is about $1.25 trillion in US. 1.25 trillion. Let me tell you, Indian economy at this point of time in 2018 is a $1 trillion is a $1 trillion economy. So world over, if you see, in the US itself, the inventory is actually equivalent to the GDP of India, $1.25 trillion. This figure accounts to almost 25% of gross national product of US itself. If you are comparing with an Indian marketplace, that's US inventory is as equivalent to the Indian GDP total. And this percentile doesn't really differ much in majority of countries. It's almost remain the same. Enormous potential for efficiency increases by controlling inventories. Now, when we are speaking of inventories, which you keep it as a holding cost, now important to understand that there involves cost to hold it. Now, why is this cost? If you're saying the bigger corporate said $1.25 trillion means something. Why it is a cost? Because the stock is lying out dead there. There's no movement, and plus there's a holding cost, and we'll speak about that in as we progress. That there is a holding cost. We need to take care of it. There could be a pilferage or a theft loss. It could be reducing shelf life of the product based on the industry that is serving. So the product which lies at the level of stocking out has itself a risk element, and every day depreciation happens as well, normally as well. Depending on the industry wise, the depreciation percentage varies significantly. If it's in the food product, for example, we know, let's take an example of bread. Now, any food product or edible product you see, the shelf life. What is shelf life? The life from where it could be consumed. In a product like bread, we know if you go and check the shelf life of a bread, you will find that maybe 4-5 days. That's it. So 4-5 days if it is not used, and if the offtake doesn't happen from a bakery or from a service providing good or a mall, then the product reaches the value of 0 within 4-5 days. That means you can't overload the stock. neither you can decrease the stock as well. So the point at this level, why? There is a huge corpus and amount associated with inventory. And managing inventory, taking decisions on inventory, controlling inventory is one of the ways through growth could be optimized, through growth could be maintained. Now, they say for an organization to grow, there are two ways to go about it. One, the company increases revenues or sales of its product or services. That's one way to go. There's one way the company grows. The second way is, even if your sales doesn't grow much, say for example, hypothetical, even if the sale doesn't grow much, the company can still grow year on year if you reduce the total cost of your inputting cost from raw material to finished product. One way the point B increases in terms of unit sales. The second way is you reduce your fixed cost and a variable cost and inventory cost of the product. If you can do that, the company can still grow. Ideally, both the sales should go up, inventory should the inventory cost should come down. Ideally, if you really want to optimize business well. So, when we are speaking of inventory control and planning, it is detrimental, friends, that we work because it's a high value. It can give success and give growth to the organization as well. If a company grows, one of the ways to go is go and cut down on inventory. So, reason why we are doing it, there's a huge proportional corpus value to it as well when it comes to absolute money as well. Let's look at the firm level. So this is the macro view, the world overview, or even the national view. Let's look at the organizational level. At a firm level, sales growth, right inventory at the right place at the right time. When it comes to the company's perspective, inventory means your product or service should be available at the right proportion, at the right place, at the right time. So these are the variables as well. It's not just your product should be available, because two different places. For example, if you are into selling apples for that matter, and we know the demand of any product state-wise changes, even location-wise changes, region-wise changes, station-wise changes, the route-wise changes, cluster-wise changes. So it changes differentially. So it's also dependent on the place. So inventory should depend on one, the product, the place, and time. When we say of time, different seasons have different demand times. For example, ice creams. We know when you speak of ice creams, the major time to do business, if you have seen in the ice cream industry, is primarily begins from March, April. From March, April to August is what the primary time is. September, November onwards till Feb, March, it's a lull phase when you are speaking of ice cream industry in an Indian context, right? So there is a place element as well. So for an ice cream industry, when we speak of inventory, even if you generalize all locations, which will be differential, but if you want to generalize as well, your inventory has to be robust and rich when you are speaking of the time zone from March to July, August, because that's where your demand and hence your sale goes up. So inventory, is it a function of demand? Yes. Is it a function of time? Yes. Is it a function of place? Yes. So the time variable, cost reduction, less money tied up in inventory management and obsolescence. That means we mentioned that there are two ways for a business to grow. Number one, increase sale. Number two, optimize inventory. Now there's a difference between reducing inventory and optimizing inventory. What's the difference? And students, the difference is, what does reducing inventory means? Reducing inventory means you keep on, whatever inventory you had, you keep on dipping down. The point is, till where? Can you go to zero inventory? Is it recommended? Not really. Why so? We mentioned that if inventory falls below a certain level, it can actually give a loss, because sometimes there might be an opportunity loss where the inventory has gone so low so that now from a product, from a manufacturing side to reach the end retailer where the customer buys the product, it might take a travel time, and hence a business might be lost, and hence an opportunity loss as well. So we are not speaking of reducing inventory, we are speaking of optimizing inventory, and that's detrimental. Okay, why do we care? Let's take an example to really substantiate, a business example to substantiate this. So each of the Solectron's big customer, which includes Cisco, and we are speaking of a software development company, an IT development company, and since Cisco is an IT software development company, Ericsson and Lucent were expecting explosive growth for wireless phones and networking gear. When the bottom finally fell out, it was late for Solectron to halt orders from all of its 4,000 suppliers. Now we are not just looking at the base of the suppliers, 4,000 suppliers. So we are not speaking of suppliers of 5, 10, where you can really micromanage things. We are thinking of 4,000 suppliers. Now Solectron, now look at these numbers, they are staggering, friends. Solectron is a company through which their customers are Cisco, Ericsson, Lucent. Now Solectron has a $4.7 billion inventory. Now we are speaking of 2001 example. 2001, $4.5 billion inventory. Let me tell you, Indian context. They say anything above a $1 billion company is considered to be a big company. 5 billion, close to a $5 billion inventory with one company. Is that huge? Yes. So when Palm formally reported quarterly numbers in June, the damage was gruesome. That is, it was really big. Its loss totaled to $392 million, a chunk of which was attributable to writing down excess inventory. Cis Caballon said that unexpected earnings decline is the consequence of higher than anticipated excess inventories. So one of the primary reasons for losses were very high inventories. So when a company, the learning that we need to draw from here is, when a company is running into losses, one of the reasons could be lack in sales, right? The second contributing factor is also inventory. So maximum time you will figure out that when company is in a downhill or when a company doesn't do well, what are the normal symptoms you will figure out? They will figure out how the entire process could be lean, could be really chunked down, could be really thin, and hence you will find a lot of layoffs happening. You will find certain processes being optimized. You will find salaries are not going up seriously. So the point is, it's about everything getting very lean, very much lean. So example wise, what we are trying to figure out, friends, is that when it comes to inventory, the cost is also immense and huge. And hence, whatever the size of the organization be, friends, it is important how we maintain our inventories, and we are looking at how to plan and control well as well through various models. Just to give an analogy and be on the same page, how does inventory affect individually? How do you manage your inventory at an individual level or our inventory? Let's take an example. How much do you buy and when? Now let's take simple household products like soda, milk, toilet paper, gas, cereals, whatever. Let's take an example of milk. You know that milk is a daily consumable product for every household, for a lot of them I mean to say. So tell me that how much of inventory do you keep milk as a reserve? Now let's also delve and understand this better. That means whenever you go to purchase milk, how much do you buy? Number one. Number two, imagine that you are buying daily, say for example. And if that's the case, how much do you buy? Let's take one of the prime factor that would be responsible, definitely the demand or the sale in this case. That means that how much do you consume milk? Say for example, a family of 4 consumes roughly say 1 liter or 1.5 liters, say for example, for milk products, milk itself, coffee, tea, any of the beverage, whatever. So 1.5 liters is the consumption per day for a household of 4 or 5. And assume that the family buys the milk every day morning or a fixed time of any particular day. Now, would the family buy 1.5 liters only is the question. For a lot of us, you'll find people tend to buy 2 liter or possibly 2.5 liters as well. Yes, why? Because they know the consumption itself is roughly 1.5 liter. So what factors now will drive to buy 2 liters of milk every day? Number one, possibly what if guests come up? Now what if guests come up? What if you are preparing a new dish or a new beverage? What if you don't get really time to buy milk at that particular same time? So suppose if you tend to buy milk every day in the morning, suppose that doesn't happen and you are forced to buy maybe afternoon or evening, could your entire calculation may toss up? Yes. What if, let's take some extreme scenarios as well from a discussion perspective. What if there's a strike of transportation or truck through which the milk comes to your retailer, and you got to know that 2 days there's a strike of transport and hence milk is also one thing that you will not get. Now, would you buy more? For sure, yes. Now that inventory that you are keeping of 2 liters, half liter more than your consumption, possibly could swell to 3.5, sometimes 4 liter also if you hear this news. Yes or no? What if you hear the news, the prices of the milk are going to go up because of whatever taxes or so and so forth, or the company intends to raise the cost? Could your inventory at that point of time, when you hear them, can go up? For sure it might. So there are various factors. Let's take some few other examples, some other factors. What if you hear that the price is going to come down? Now understand, don't get stuck by the example of milk. Now, milk is just an example to elaborate various parameters, because context to context many things change. What if you came to know the price of milk is going to come down? Would you still buy 1.5 liters of milk? Not really, isn't it? You might think, okay, let me buy this time around only 1 liter or possibly half liter, because we know the next lot or next day or maybe by evening you can get a fresh stock which would be at a lesser price, and that's benefit. Now from a household perspective, this pricing really might not matter much, isn't it? As a milk as a product works out to be around 40-45 odd rupees per liter. But when you're looking for a business context, now these small variables, now Milk is just a product. If you look into from a business perspective, these all small raw materials all add up to big value, and that makes a difference. And if you're looking at the example per se itself, they are amounting to billions and trillions when it coming into from an entire country's perspective, and that's huge. And that's where, when you're speaking of operation management, we are looking at how do we optimize well, how we can plan and control better. So what all things do you consider? We will consider cost of not having it. What if you don't get it? Suppose if you don't get milk, let's go back to the example. What if you don't get milk? Would it hamper the quality of your life? Contextual, for many it would, because milk very much part of your habit, very much you think it's part of health. So it might, maybe tea for that matter. So what's the cost of not having it? Cost of going to a grocery or gas station, time, money, cost of drawing money. So it also depends on how much time do you need to go, or place you need to go to buy that. Cost of holding and storing, lost interest. So it's also about when you suppose if there is a huge party at your house, we go back to the same example and thinking of preparing ice cream, homemade ice cream, and for that you need roughly 10-20 liters of milk, say for example. The other challenge that pops up is how do you store those 20 liters, because your fridge, household fridge, is just a small thing. So cost of holding. Now cost of holding from an organizational context also means that when you are holding a raw material or a work in progress or even a finished good for that matter as inventory, there's a holding cost associated, because it needs to be taken care of in terms of safety, in terms of insurance, because of the insurance cost as well, in terms of the infrastructure, in terms of personnel to take care of the infrastructure. Price discounts. So we are looking at price as a variant as well, where it might go up, come down. Now, haven't you heard about schemes in the marketplace? I'm sure you might have. The schemes that you normally find apparels, where you hear the schemes of stock clearing. Have you heard about the schemes of stock clearing? I'm sure you have. In a lot of apparel industry, this happens. So what happens? Apparel industry, we know that when you're speaking of fashion or trends, which is primarily related to apparels, is the shelf life is very less. Shelf life not of the product per se. The product might last when it comes to shelf life, but trends or the fads, they take a nosedive very fast. So it changes very fast. So stock clearing means then the product which was manufactured 6 months back now doesn't hold much value today, because the taste and preferences of the end customer has changed. And this change will differ from industry to industry. In apparels, it's pretty short. In handsets, it's pretty short. So when we are looking at apparels, so what the company does it gives a discount. So if you visit malls, any of those malls, you'll find the stock clearing getting happen. So clearance of stock. If you're clearing stock, that means they're undercutting their profits. So you find these boards, buy 2 get plus 1, or buy 2 get 3, or buy 3 get 2. So what they are doing is they're undercutting their profits, and also they're undercutting their inventories. That's the key for us. How are they undercutting profits? Because they want to now clear off their inventories. Why? The product might be good even at this point of time, but it is fastly depreciating in value. And if you have a depreciating product, it's get cleared off. and that's what inventory happens. Okay, what if they don't clear the stock? Let's take that scenario. So what's the cost of not holding it? Suppose if you're not clearing the stock, what will happen? The product will die dead, and after 1 year, you don't get anything from the product because there's no demand. So because the D has changed, the demand has changed, and so the sales. And hence, any inventory of a product which doesn't have demand, or which a demand is going down rapidly, the inventory cost is going up rapidly as well. How much do you consume the demand? Some safety against uncertainty. We know that there's also a risk when it comes to holding a stock. We know that if you, let's take an example, common example, onions for that matter. Now, onion has been a very turbulent market, especially in the Indian context, where you often, once in a year, you'll find the price rocketing to 100 rupees per kg as well as onions are concerned. And hence you'll find this change of variance as well. So suppose if you're stocking your monthly consumption or weekly consumption of onion is around 2 kgs for a household. Now, what if you hear that the prices of onion are going to go up? As of now, it's running at 30-40 rupees per kg and expected to rise to 100, and you are daily seeing the increase. And if you think that, okay, let's buy some 10-15 kgs of onion and then keep it, that's a good decision because you're expecting the demand, the cost to go up. On the other hand, you also need to check on the risk element of the onion, and the risk element is how much it will last. It will start after some time, it might start rotting out. That means the onions have started getting spoiled because it doesn't have that much shelf life. It's an eatable product. You can't possibly better store mechanisms. If you can't really store well, your onions are getting degraded, and hence you can't use it, and hence there's a loss. So you need to look into the safety measures of the product as well. And so applies to business context as well. So a lot of chemicals you buy in as raw materials. So you need to put it at the right place. Vaccines we spoke about in the last module. If the inventory of vaccine is to go up for whatever reason, if you want to keep some inventory of vaccine, the additional cost also go up because vaccines we mentioned requires a specific temperature range in which they need to be stored. Now, maintaining temperature, ice cube or an ice room for that matter, is at cost in terms of electricity, equipment, infrastructure, people? Yes. And hence, those are the variables you need to factor in. Cost of inventory. We need to understand definitely what is the cost of inventory. So, what all factors contribute to holding of the stock? So one, physical holding stock. We actually physically hold it, and that means that out of pocket expenses for storing inventory, that means insurance, security, warehouse, rental, cooling, depending on whatever applies. Cooling for vaccine, warehouse if it's a mass producing product. All costs that may be entailed before you sell it becomes a physical cost. Even holding cost. If it's a warehousing, if you need to put it in a warehouse, let's take an example of Maruti. Now, when Maruti is producing a model based on the demand that they know, they always need to have an inventory as well. Inventory of whatever days that we will look into further as well. So if automobile or a Maruti car need to be stored in a warehouse, that is cost. That means the car need to be pulled in, put up at the right place, need to take care that the product is in good condition. What if there are elements of risk in terms of pilferage, theft, natural calamities like rats can spoil food products, or even automobile, they can really cut off things, spoil the things, and that adds to cost. And that cost beared by the company, because at the end time, the customer wants to buy a product which is which is up to date, which is new, which is working, which is up to its best as claimed. So there's a physical cost when it comes to inventory cost. Opportunity cost. That's the one other spectrum, and we will look into opportunity cost as well. Opportunity cost of inventory, that means that foregone return on the funds invested. So what if your inventory is so less that if a customer buys at the end as an end product, for example, if let's say Crocin for that matter, a pharma product. Now, if a customer goes to a shop to buy a medicine, and if he doesn't get it at a particular store, correct, and because of lack of inventory of the store, for that in this case, he might go to a different store, isn't it? That's the normal thing. There also you will find that particular brand of medicine is not available. Why? Because the distributor didn't have right stocks. Why? Because the company at their end didn't have enough stock. Now, what will the end patient do in this scenario? He will go back to the doctor and say, this product that you have written is not available. What will the doctor do? He will immediately cancel it or write some other product, which the customer goes to the retailer, buys the product, another product of a different company. Is that opportunity lost for that particular company because of lack of inventory? Yes, big time yes. And that's the balance that you need to strike out, and that's the decision and the planning of how to optimize so that we don't have a very high inventory on one side and we don't want to miss out on the opportunity cost. It could be operational cost. Operational cost could be delay in detection of quality problems. We know that as time passes on, generally the quality reduces of the given time because the shelf life is defined, and shelf life for any product is different for different industries. Food product, the most narrow, days, actually few days. Get into some bigger zones in terms of depending on the product, machinery, chemicals, tools. It could be from months, years, few years. Delay the introduction of new products. So if a company intends to launch a new product, say for example, and if proper inventories are not kept at the warehouse or at the company level so that it can cater to the marketplace where they are marketing or selling, that's a cost. Increase throughput time. Now, we have mentioned in our last one of the matrices that we spoke about was the throughput time. And what was throughput time? Throughput time is the time required by a product from moving through a system. Lesser the throughput time, better the returns or better the cost optimization. Inventories helps, it actually increases the throughput time and hence the operation cost and hence the entire cost as well. So it's important to see that how inventory influences major parameters. Now, if there is an opportunity loss, say for example, because the inventories were less or minuscule, does that impact service of the product? Yes. Does that impact or tarnishes the image of the product? Yes. So it impacts service as well. So what all from the slide, what is important to know is how does it really impacts in cost. Inventories impacts in terms of physical. There's a cost. There's a physical cost involved. There's also a cost of opportunity cost, and there's an operational cost element. And important to also know that how are we going to manage this and understand this through various models of how cost could be optimized when it comes to inventories. So benefits of inventory. One, hedge against uncertain demand. So one of the prime variables, friends, and we will go one by one. one of the prime variables that inventory is dependent on is the demand. How much of demand is there of your product or service at the marketplace? Yes, for sure, yes. So one hedge, what does hedging mean? Hedging means you really use that. You have proportion of your unsold stock to uncertain demand. We always know the demand is there, a certain portion of your demand, we know a predictability of demand. Yeah, based on past experience, based on competition, based on market survey, you have a demand, you get a number as far as demand is concerned. But there could be conditions where there could be uncertain demands, where things could change, factors due to political things, economic things, natural things, social demographic things. It could change a lot, isn't it? Now we spoke about the Paytm example. Because of demonetization, 2,500 fold times increase in customer base 3 months. Is that uncertainty at its very best? Yes. So there are uncertain elements as well. So how does inventory help? It's to hedge against those uncertain demands. So in fact, from a business perspective, it means that your inventories should able to cushion few spikes in your demand. So if there is a small increase in your demand as well, your inventory should able to absorb that. Let's go back to the milk example. Suppose the consumption is 1.5 liters per day of an household. Even if 1-2 guest comes as well, buying 2 liters helps. For sure, it does. So hedging against uncertain demand, hedge against uncertain supply. So we spoke about in the milk example, transportation. The goods is available to the company, the goods, but the transporter is not there. Supply is not being done due to whatever reason. It could be transportation strike, it could be difference in taxation structure, it could be local sambandh. So it could be any of those issues of supply. So you can hedge against that. Economize on ordering cost. So we are also looking at inventory cost and ordering cost. Now understand, one of the variables we spoke about is demand. The second, we are looking at supply. Factor that also depends is ordering cost. Understand, if throughout the entire supply chain, right from a retailer, distributor, super stockist, warehousing, any marketing intermediaries of a supply chain, whenever an invoice is raised, whenever bill is prepared, there is a cost associated with it, and that is important to understand us. So there's an ordering cost, and we will factor that when it comes to calculus. Smoothing. So it's also about the ease of operation. Now inventory cost is also about how do you really make it, optimize it. It's the smoothness of operation. So to summarize, we build and keep inventory in order to match supply and demand in the most cost efficient way. So the entire objective when we are planning and managing inventory well is, how do we really optimize costs so that the supply and demand is met well. So modeling inventory in a supply chain. So we are looking at inventory from a supply chain. So let's look into a very basic infrastructural model. So that from this slide onwards, you will find a lot of visuals, and for visual learners sitting out there, it would be a great experience, because we generally, and they say roughly 60-70% of entire world population are visual learners. We love visuals, and that's how we love cinemas for that matter, and because they're visual elements. So a lot of our slides, forthcoming slides, in fact all of them from here on almost, would be visually depicted. So let's look into the graphical representation or the pictorial representation. So we have a supplier, that's where the company end is. So we have a supplier who supplies products. represented by yellow blocks, and we have a warehouse where stocks are kept, and we have the retailer. That's where the end product is purchased by the customers. Now, if you look into each zone, we need to understand that the zones reflect the different demand cycles as well. So if you see on the right hand side, you'll find the maximum arrows because the maximum consumers are attached there. So with this, let's take an example to substantiate this. So when you speak of an inventory perspective, at every level of this slide, there requires an inventory. Inventory at the supplier, inventory at the warehouse, inventory at the retailer. This and that too, different products, different time. So let's take an example with the same model of a home depot company. Who is into home products, furniture, decor, mattresses, so on and so forth. So for this company, inventory consists of up to 35,000 different kinds of building material. Now, when we were getting to the example of a milk product, it was so simple to understand, isn't it? Just one product and you get so many dimensions about it. But when nitty-gritties are more, 35,000 products. Now, are you getting the SKU definition? 35,000 building kind of different material, home improvement supplies, and lawn and garden products. So 35,000 kind of different stuff is available when it comes to Home Depot as a company. We currently offer thousands of products in our online store. So there are two models that they operate on, which every organization these days has. Number one, they have their own supply chain network where they have their own distributors, their own retailers. One of the channels of sales, the other channel definitely for all organizations, if you see, is also the online sales. We offer approximately 250,000 more products through our special order service as well. So we have a differential kind of supply chain that exists right from the direct channel sales through distributor, retailer. We also have the online model and also special service as well. So what we are drawing on from this model is there's an array of products and different channels of sales as well. And the crux of the matter is, how do we now optimize each raw material as well? For that to understand well, we would be understanding inventory planning and control by having various models. And these are models that have been tried and tested primarily from the period of 1950s. We mentioned that in one of our earlier modules as well, that one of the way to grow is through optimizing inventory as well. And lot of the inventory management came from model of Southeast Asian countries, especially Japan in particular. And we mentioned earlier as well that post-World War, majority of countries, not only Southeast Asian countries of Japan, Malaysia, Singapore, but also European countries, Germany, Italy, UK. If you see post 1940, that's the World War II, there was a slowdown of economy, which is natural bound to happen because of lack of infrastructure, lack of the entire communication network itself. So what had happened is when you don't have a great demand, what companies were doing is they were optimizing how at the back end, how going reverse engineering, we can really optimize cost, reduce inventory, introduce lean practices, introduce methods, systems, models in such a way that we really optimize our resources, and inventory is a resource, to the very best. This is how the backdrop of how inventory management came up. So 1940s, 50s onwards, you'll find a great scientific approach of how inventory needs to be done, managed well. Although inventory management on a gross level was definitely done 2 generations ago. But from post-World War, 40s, 50s, there was a more scientific approach and model through which it was addressed. So there is a multi-period model which primarily is based upon the repeat business or multiple orders. And then single period models where there are single selling season, single order. So the model that we select to plan inventory is also based on what kind of industry it is and what kind of demand cycle they have as far as time variability is concerned. So when we speak of multi-period model, what does it mean? It means that on one hand there is an inventory, and second hand we have a supply as well. And the key question is in a multi-period model is, one, how often to review, two, when to place an order, how much to order, how much stock to keep. So whatever kind of industry you're in, these are key questions. And when we speak of Home Depot like product, as an example also, 35 different SKUs, a smallest keeping unit or a service, 35,000 variables that you're playing with. Now with this, how much to order, when to order, how much stock to keep, when do you order, at what time, at what stock it would have happened. These are key questions to be asked as well. We also need to take into account the ordering cost, holding cost. So ordering cost and holding cost are the variables when we speak about operational cost. So let's now get into some abbreviations which we would be using throughout. So see to it that you have your full focus and attention on the next coming 3-4 slides, because that's where we are going to define a lot of variables with abbreviations. So if you want to drink a cup of glass of water, do that now, because they say a lot of time we need to ask ourselves, and that's a good question to ask at this point of time as you're listening to me, what is your attention span, on a 0 to 10 scale? Where are you now? So rate yourself, 0 being the less and 10 being the maximum, how much attention you're having at this point of time as you're listening to me. So if it is around 8, 9, even 10, great. So if it's around 4, 5, 6, which is less when it comes to receiving data, drink a glass of water, change your body posture, be there. Because they say that if you really want to gather much as learning, it's important that your listening has to go up. And listening is a great art, and we really need to listen well to learn well. So I hope that sets the pace. And so coming 3-4 slides, we are going to deal with a lot of abbreviations which will be relevant from the entire slides that we are going to take it forward. Okay, so multi-period model, the economic EOQ. EOQ is one of the models through which inventories are planned and controlled. What does EOQ stand for? Economic order quantity. I repeat, economic order quantity is one of the tools through which we plan and control inventories. So we know there's a demand. Demand first hits the retailer, then gets to a supplier. Let's define once again primary economic terms. What is the demand? Demand is known as the deterministic D. So we'll define demand. What is the demand from the marketplace. So abbreviation for demand is D, which is units per year. Based on the industry type, that could be further defined into months, weeks, days also, but from a entire calculus perspective, we will define it in a year term. So what is the demand? Demand is units D, represented D, units per year. We have a known ordering cost. We mentioned that there is an ordering cost associated to prepare an invoice, some personnel of accounts of finance to feed the data. So there is an overhead cost of the salaries as well. So there is an ordering cost that we will represent by S. And immediate replenishment as well. So S is an ordering cost. Annual holding cost of average inventory. Let's define holding cost. Let's abbreviate it by H per unit. The holding cost would be H per unit, and we have also purchasing cost C per unit. So we are looking at 4 variables to start off. D, demand; S, ordering cost; C, purchasing cost, and we also have the holding cost H. So we'll start with these 4 variables, and we will try to put this in a calculus. I want you to have an absolute focus now onwards, because there are a few calculations involved. So be at your very best when it comes to learning and attention. Okay, so we know the total cost of the product. Now I'm re-emphasizing the point, difference in cost and price. I hope you're aware. If you're not, I'm repeating. What is the cost? Cost is the actual cost incurred by the company by physical money. Price is the perceived value. The pricing could change. The cost is absolute in numbers. When it comes to the financial element and understanding of cost, total cost is the purchase cost plus ordering cost plus inventory cost. So we know the cost definitely is the purchase cost. What all purchase costs? Purchase of inventories, purchase of raw materials, purchase of infrastructure, machinery, whatever is required. Ordering cost, we know there's an ordering cost and there's an inventory cost as well. That is the total cost. So purchasing cost would be total units into cost per unit. Ordering cost, if you want to still further bifurcate, would be number of orders into cost per unit. So we know that ordering cost will go up if more number of orders are processed. So that also means their ordering cost comes down if there are low orders. Inventory cost is the average inventory into holding cost. So we have an asset value of the products, that's an average inventory, and then a holding cost associated. So these are few variables and few interrelationship mathematically. I repeat, total cost is purchasing cost plus ordering cost plus inventory cost. Purchase cost is units into cost per unit. Ordering cost is the number of orders into cost per order. Inventory cost is the average inventory into holding cost. And now let's fit in this with now few graphical models, and these are interesting ones as well. So finding the optimal cost of the optimal quantity to order. Let's get into part of planning. We are planning. Let's get an overview. What are we doing? We are in the topic of planning inventory. Why we are doing that? Because we know there's an element of cost involved and service involved, 2 functions. So our key agenda or module would be finding the optimal quantity to order. Let's go back to the example. What the question is? If your household consumption of milk is 1.5 liter for a household of 4 5 people, how much of milk would you buy if you are buying once a day? Is the question at a very micro level. That means how much quantity would you order? Let's say we decide to order in batches of Q. Now for a milk, we know it is once in a day, sometimes twice also, isn't it? So let's define that we are ordering, since we are looking from an annual perspective, we will not order once a year. Yes or no? Why? Reason being to accommodate flexibility in demand and flexibility in supply as well. So we are ordering Q, batches of Q. So let's come to this axis, very important point because we will be looking into graphical model into X and Y axis. Let's look into what is X. X is time. What is Y? Y is Q. That means batches to be ordered. So on x-axis we are finding that if you look into, there's a demand that is going up. If you see, the demand started off with this point Q, came down, again went up. So this period, if you see, in which the demand Q has occurred, is the total time. So we have seen the total time. At every point of time the inventory comes down, we purchase the next. So once the demand is here, it comes down and we want to take this over here as well. So Q, you will find the batches to be ordered as well, where the number of periods will be D divided by Q. The next graph will be more clear as we mentioned. So the part of the graph which is marked by red is the average inventory for each period. Now the period might be monthly, quarterly, fortnightly, weekly, depending on industry to industry, it changes. Milk example, it was daily. So average inventory for each period is Q by 2. So finding the optimal order to quantity. So what is the end objective? End objective is how much of quantity should it buy. So purchasing cost is equal to D into C. That is, what is D is demand, C cost. Ordering cost would be demand divided by batches of the product into S, ordering cost. But inventory cost is equal to the average quantity to be ordered, that is Q by 2 into holding cost. So mathematical correlates an equation, but these are certain formulae that helps, since we are working out how much quantity need to be ordered in inventory. These are few mathematical tools that help you to understand this better. So what is the total cost? Total cost is equal to demand, DC, demand to cost, plus we have DQ divided by S, we have an holding cost, and we also have an inventory cost. That's Q divided by 2 into H. In order to find the optimal quantity, we need to optimize the total cost with respect to decision variable, the variable we control. Now the point is, can an organization control demand? Some ways, yes, isn't it? How? By influencing marketing, sales, you're influencing demand. But that's only part control. Can you control your ordering cost, holding cost, inventory cost? Yes. Can you have more control vis-a-vis the demand? For sure, yes, because lot of your variables when it comes to holding cost, ordering cost, batches we order, is completely dependent on the organization. Let's go back to the milk example for an analogy. How many guests might come at any given day? You really can't control, isn't it? Yes. But when are you going to buy? At what quantity you are buying? Definitely depends on the person. Going by a similar analogy. So which is the decision variable? Definitely the inventory. So when we are looking from economic order quantity, so economic order quantity EOQ, the model for defining how much quantity to be ordered, optimizes inventory, optimizes cost, optimizes value in that point from A to B. So EOQ, or economic order quantity, the model that we are discussing, the objective is how much quantity to order, and this graph is an interesting explanation to it. Again, x-axis, let's take what is x-axis? X-axis is quantity, y-axis is cost, and we are looking at three variables. Let's look at ordering cost. Now we know that as the quantity increases, your ordering cost comes down. Yes, because of a repetition cycle, optimization, economies of scale. Let's look at holding cost, represented by the blue or the violet line. Holding cost with increase in quantity goes up proportionally. The cost goes up proportionally right from the point 0. Seeing this? Holding cost goes proportionally. And if you want to take this inference from a total cost, you get an intersection. If you see this chart, the intersection point gives the optimized point of quantity to be ordered, when you will find that the ordering cost and the holding cost is optimized, and your total cost, if you see, the graph will come out like this, would be at its lowest point when it comes to quantity. This is the graphical representation, and we'll also want to look it into from a numeric perspective as well. So there is a trade-off between holding cost and the ordering cost. We are just looking at this point of time only two variables, the ordering cost and the holding cost, when we are defining inventory cost. Okay, so when we speak about economic order quantity, now let's come to some numerics. Q star, or quantity to be ordered, would be under root of or square root of 2 into S into D divided by H, where S is the ordering cost, D the demand, and H the holding cost. So we know the let's look at a very broad definition of it. We are seeing that the ordering cost is direct function of or to be ordered. So it works out to be that, assume, let's take this as an example so that we can really define this well. Assume a car dealer that faces a demand for 5,000 cars per year. Now let's get to the numbers clear, because we will stick to this example, and this is a good business example to stick by. There's a car dealer, let's take any showroom person, where the demand for this him is 5,000 cars he sells every year. That's what, based on his past experience, is. And it costs around $15,000 to have the car shipped to the dealership. That's the cost involved. Holding cost is estimated as $500 per car per year. How many times should the dealer order, and what should be the order size? If these are the variables, let's get the variables clear. Number one, there's a car dealer that faces a demand, 5,000 cars per year is the demand. Cost to be shipped is $15,000, and we also have the holding cost of $500 per car. Question is, how many times should the dealer order, and what should be the ordering size? So if you fit in with this formula, the quantity to be ordered, it works out with 2 into 15,000 into 5,000 divided by 500 is equal to 548. That means 548 should be the the order number. So that means he should order 548 cars. 548 cars, and we'll also look into at what frequency, the batch size. So if delivery is not instantaneous, now let's now come in with variables. What if delivery is not instantaneous? That means it takes time to deliver from the dealer to the supplier. But there is a lead time L. So we are now introducing another variable L, the lead time. When to order, how much to order. So we know time is to order quantity, Q. There is a variable as well. And the variable starts as this. Suppose this is where your quantity becomes 0. Because your inventory is represented by y-axis, it will become 0 because there is a demand coming in, sales is happening, it will become 0. Would you place an order when it becomes 0? No. Why? Because there's a lead time now L. If you place an order when your lead time, when there is a lead time and when your inventory is 0, can there be an opportunity loss? Yes. So we want to factor in at what time, and we are going to optimize that as well. So there's a lead time as well. So there is a lead time between placing an order and receiving an order as well. So what do we do? So D is the demand per period and L is the lead time per period. So we want to look into ROP, or the reordering point. At what point of time an order of 548 is what we have derived, the economic order quantity, should be placed, would be L into D. That means what inventory would be the reorder point, and how much shall we order is the economic order quantity. So let's continue with the same example. What if the lead time to receive car is 10 days? Let's assume that after placing the order, it takes roughly 10 days to receive the order. Say for example, the car dealer. When should you place the order then? So since D is given in years, so we'll convert that into months. First convert to days, since we have 10 days the lead time. So we'll convert into days, 10 to 375. So we have R, the reorder point would be 10 divided by 365 into D, that's 5,000 the demand, 137. So 137 is what it comes out to be. So when the number of cars, so what is 137? So when the number of cars and in inventory reaches 137, the next batch size of 548, which was the economic order quantity, should be placed as an order, because it takes a lead time to 10 days to reach. So that's about the lead time. But we know we are all assuming in this case that the demand is fixed of 5,000 cars per year. That's what we are assuming. But this assumption can go wrong, for sure. Yes. What factors, especially if it's in a case, an example of car itself, tell me what all factors will control and influence demand. One, the price and component parts of the automobile has come down. Can it increase the demand? Yes. If the taxation, tax structure of automobiles has gone down or gone up, would that influence demand? Yes. Better finance structure now is available in terms of loans, in terms of EMIs, longer periods, easy to processing. Can that influence demand? Yes. Increase or decrease in fuel charges, be it CNG, petrol, diesel, can that influence demand? Yes. So what if demand itself is changed? How will this now change? So what have we come till now? Economic order quantity, the quantity we should order when the sale is 5,000 cars per year. So we have arrived at 548 should be the economic order quantity. We have also looked into what if there's a lead time of 10 days. We mentioned 137 when the stock reaches, so you should order the next 548 cars. Now we are looking into a third variable because there are multiple variables we need to address. What if the demand is not really stable? So we know that the order quantity will keep on changing because your demand has been flexible. So we will find few challenges with that, and the challenge is when should be then the reorder point if we are seeing fluctuation of demand. So we have mentioned that 5,000 is what the average demand is on year, but monthly it might keep on changing, and possibly this year it might touch 6,000 or it might dip to 3,000. So there's a lead time demand as well, because demand we have spoken for a year, month on month also it changes, and hence inventory also need to be changed month on month. So inventory at the time of receipt, there is a difference as well. So you're finding this demand changed due to change in fluctuation. So we need to accommodate this as well. The stock out point. The stock out point would vary between increased demand or decreased demand. Yes or no? If there is an increase in demand, can there be an unfulfilled demand and your stock will be emptied soon? Or let's take the other one. What if the demand goes down, you have higher inventories now. So now we have a plus and minus variance as well of demand, which we need to factor in our equation. So there is an unexpected demand. So there is a factor in. If you see this dotted area with the balls, this is an average plus or minus variance of demand, and in every industry, every type of thing, this keeps on happening. So how are we going to accommodate this change in demand is what we'll also look in. Okay, so to reduce stockouts, we add safety stock. Now, when we are discussing inventory management, planning and control, this definitely is how we are planning and controlling it well with the change in demand. So there is an inventory change, the expected demand has dipped or it could be increased. So the lead time changes. So what do? So we need to keep a safety stock to factor in the additional demand as well. So ROP then changes where safety stock plus expected demand, the lead time difference. So order quantity Q in this will change, wherein because we don't want to really miss out on services being offered as well. So we want to change as well. That means that decide what service level you want to provide. Service level is probability of not stocking out. How do you define service from an inventory perspective? Service from an inventory perspective is as equivalent to probability of not stocking out. So the stock should not be zero. So if you want to give 100% service, we need to figure out the stock should not be zero. So if you want to figure this out, how much safety stock you are going to keep so that your product is optimized, you are not stocking out. So read Z from normal table from a given service level. Okay, let's take a standard deviation as well. Now variance over multiple periods, which is the sum of the variance of each period assuming independence. So we are looking at every month in the same example of car, at every month, every fortnight, every quarter, this variance will happen. So standard deviation over multiple periods is the square root of the sum of the variances, not the sum of the standard deviations. We are looking at a square root of, we are still factoring in an element, and the factored element becomes the average inventory. Then in that case, when you want to absorb that safety stock as well, would be order quantity divided by 2 plus safety stock. So we have a change in demand, as you can see from this graph, and we want to accommodate this SS or safety stock so that we have an EOQ divided by 2 plus a safety stock to be taken care of. Mathematically, how to find the reorder point and the quantity in this situation? It would be something like this. So order quantity would be EOQ is equal to square root of 2S into H, S into D divided by H. To find the reorder point, determine the service level, that is the probability of not stocking out, and this comes through calculus. Find the safety factor, and these safety factors are driven out by research, by statistical calculations as well. Find standard deviation in demand and square root law. So, which accounts to safety stock is given by SS, where is safety factor into standard deviation. The reorder point would be ROP is equal to expected demand plus the safety stock. The average inventory is equal to safety stock plus EOQ divided by 2. So we are going to factor in two elements, the economic order quantity and the safety stock. And if you go by this calculus, now in important friends, there are a lot of numerics and analogs involved in it. Don't be boggled about by that. We are interested in the calculation. We need not be mathematicians to understand it, but this comes from a research. What we would come up is, if you go back and apply the formulae, this is an example, it would be that rack back to the car lot. Recall the lead time, what it was, 10 days. And the expected demand was 5,000. You estimate the standard deviation. We have now want to factor the deviation, the variance, which, let's take an example, let's D, the variance. When should you reorder? If you want to be 95% sure you don't run out of cars. Now, the question is, why 95% of time? Why not 100? The point is, when you speak of, and this part of service level, if you want to reach really 100, that puts real additional cost. Even from moving from 99% of service cost, that means you don't want to get stock out. From moving from 99 to 100% service efficiency when it comes to stock out, there is a huge cost involved. So we look industry standards, 95% stock out. Since the expected demand is 5,000, expected demand of the lead time would be 137. Now we are introducing the standard deviations. So with service level of 95, it would be 0.95, that is 1.65. So the deviation reorder point would be 137 is the fact, it was the reorder point, plus 1.67 square root of EOQ plus is equal to 168. So order of 548 cars when the inventory level drops to 168. What was there earlier? 137. 137 was the inventory when we used to give the next order. Now we have also factored another variable. What was that variable? What if the demand changes? So we are also factoring in with the service level of 95%, if there is a change of demand, when your inventory of car is 168, you place the next order. So getting into details of this, and this is an interesting concept. So we are looking into this conceptually, and we need to figure out how things work out. So we look into inventory. So inventory is we will take few things which, so since today's session, you will find a lot of calculus, lot of keywords which are different, but important, we will try to touch upon, repeat on few things. The intention for doing that, it gets imbibed. So inventory, again, stock of the store of the goods. Now there could be an independent demand or it could be dependent demand as well. We know that demand could be influenced internally, factors like sales, marketing, if you want strategic planning. Independent demand, you don't have much control about political situations, all the pistol, the political, economic, the socio-cultural elements define that. So independent demand is uncertain. Company don't have any control about. Dependent demand is certain. We can have a major influence about. For example, let's take an example. Discounting. If discount is given, would the demand increase? Yes. How much to give is a call and a decision to be taken. The models, one of the models was EOQ that we spoke about. So independent demand is the finished good items that are ready to be sold. Example, the computer. We are speaking of the independent demand. The dependent demand are the components of the finished products. Now, we know that in the case of computers, as an example, independent demand is the absolute computer, the finished product. The dependent demand are the raw materials of the computer. It could be the parts that make up the computer. And we know for a company, they might not really be manufacturing those products. They might be outsourcing it. They might be taking it from a subsidiary company. So the company doesn't have much control about this one. Types of inventory. We also need to figure out certain types of inventory that exist. Raw materials and purchased parts as well. Partially completed goods called the work in progress. Now we have spoken about work in progress. So when we spoke about inventories, we spoke inventory could be on raw materials, inventory could be on work in progress, inventory could be on finished goods. Work in progress are partially completed goods. Now let's take an example to know what does work in progress means or partially completed goods means. Let's take an example. So let's take an example of a cake. Cake, we know that for preparation of cake, we need various raw materials, right? From batter, sugar, the ingredients. We need to bake it in an oven. So every part is an inventory. Now suppose if through raw materials we make a batter. Now batter itself could be an inventory point, or in battle, a batter itself is the work in progress. So what bakers do is they can prepare batter differentially based on what kind of cake to be prepared, and that's the stock to order matrix that we spoke about. So that is work in progress. Finished good inventories. In our example of cake, it's about how many end cakes are available to display the retailer batch which you could sell. So manufacturing for merchandise, retail stores. Types of inventory. We'll also want to figure out what are the different types of inventory that exist. That means that replacement parts, tools and supplies. Goods in transit to warehouses or customers. They could be differential that way as well. So we have inventory when we spoke about. It's also not only about the holding stock, but there's, in the example of the car, there's a lead time of 10 days we spoke about, where 10 days is what it takes time from leaving the warehouse to reaching the car dealer. That 10 days is also part of inventory because it is not yet sold. So goods even in transit is inventory. Functions, if you look into, are to meet anticipated demand, to smooth production requirements. So one aspect that we didn't spoke about when you're speaking of planning and control of inventory is, imagine we know that every plant, let's take an example of manufacturing setup. Every plant, if they have got machinery, infrastructure, boilers, turbines, ovens, they need time for servicing as well. They need time to service it well, to keep rest, to clean as well. Now, if the organization has sufficient inventory to match this up, they can smoothen this really well, and hence it smoothens the production requirements. It decouples operations as well. So from an operations standpoint of view, it really helps to have a better control if you really optimize inventories. To protect against stockouts, so we have always spoke about the opportunity cost. So an organization don't want the demand is there and the company doesn't have product to sell, a finished product to sell at that point of time, because that's detrimental. That really is a business loss. Even if you have an exclusive product, let me tell you friends, that even if you have exclusive product, not all customers wait these days, and we are living in a time where speed matters. So customers will not wait, even if you're in a very niche segment. Let me tell you, let's take an example of an Apple itself. Even for niche product like iPhone is there, few customers would wait if it's a waiting time. Not all would. Some might get to some other things because they don't want to wait so long. Now we are speaking of a very niche segment, like when you have such a big brand like an iPhone. Imagine of the other ranges of other Me Too products where things would change very dramatically and drastically. Functions would be take advantage of order cycles. We're looking at how to optimize the cycling time and hence the throughput time as well, to help hedge against price increase. So inventory also need to be planned in accordance with price increase. What if with a new budget the taxation changes and the prices of the raw materials are going to increase 3 months down the line? Say suppose this is the information the company gets it. Is it worthwhile now to increase inventory? Yes, because you're hedging against price, and at some point of time you can still increase the end price of the product because of increase in raw materials, but your actual cost has not gone up, because your perceived value of pricing might go up, but your cost has not changed. I hope you're getting this difference. I repeat, the perceived value of the product has gone up because people think. Let me give you another example to substantiate this. For example, fuel prices have gone up, say for example, and gone up by 10%, hypothetical. If you go to a vegetable owner and he says the vegetable that he used to sell a week back, now it's very expensive because the transportation has gone up. For an end customer, that's perceived, okay, I know the fuel prices have gone up substantially and hence this has changed. So the perceived value has changed, but possibly that vegetable owner, those are homegrown vegetables for him, or possibly that has not yet impacted. So the cost has remained the same for him, but the perceived value has changed, and hence he can hedge against price increase. To permit operations, to have a smoothness in operations as well, it really helps. To take advantage of quantity discounts. So we are also looking at, we spoke about stock clearance, we spoke about giving discounts to take advantage of festival time. So a lot of time you'll find that, speaking of the world context, Indian context as well, any festival time, right from Diwali, Christmas, Eid. What happens is since selling and demand is more of an emotional journey as well, lot of companies give discounts and bonus offers. Reason? Because perceived value of buying things is slightly different in festival time. People tend to spend more in festival time than normal days. Now, with this in the backdrop, the psychological equation, people also have a pull strategy as well, giving discounts. So people already are having that emotional splurge to spend, plus there is a discount. So there is both a push and a pull mechanism. So in those phases as well, we spoke about the big bazaar offer on 26th Independence Day and Republic Days. We always know of the Amazon big sales. So on these days, hence when we are looking into from an operational management perspective, you need to have great inventory control and planning, because the turnover then is in billions, and hence to mobilize this to keep the inventory channel becomes very detrimental. Objectives of controlling inventories being to achieve satisfactory levels of customer service. Now, why we are saying satisfactory? We are not saying 100% customer satisfaction. And what does customer satisfaction means? From an inventory perspective, it means cost of no stock. So we want 95-96% is the industry benchmarks. So to achieve satisfactory levels of customer service while keeping inventory cost within reasonable bounds. So levels of customer service could be really optimized. Cost of ordering and carrying inventory also could be optimized. So inventory turnover, if you see, is a ratio of average cost of goods sold to average inventory investment, and these are important for estimating cost inventories. So when we are looking at from managing and controlling inventory system well, the factors that we need to keep into account are this. One, a system to keep track of inventory. A reliable forecast of demand. We need to have this database on demand really well. Knowledge of lead times. What are the lead times or order cycles we need to keep an order on. Reasonable estimates. Should be aware of holding cost, ordering cost, even shortage cost for that matter. And a classification system need to be get into. Counting system. What are the counting systems we should be aware of? Aware of periodic systems, wherein physical counts of items are made at periodic level. So even when we speak of inventories kept at a warehouse, need to really count in well, manage well, because there is always a chance of theft, pilferage, product getting damaged because it's not managed well. So periodic counting is important. Perpetual investment system, that means that we need to keep on upgrading it, means system that keeps track of removal from inventory continuously, thus monitoring current levels of each item. Now monitoring becomes handy because let's take a product which has a defined shelf life, and after a certain point of time, cycle time, we are always reordering the next lot. Monitoring also means that the first come, first go, that means the inventory that comes in first has to go out first. Imagine a situation if it is a first come last go. For example, you have an inventory already, the new inventory has came in, and when a new demand comes in, if you're putting in the new inventory, the old stock keeps on lying and sometimes might expire, and that's cost. So inventory counting system also is a two-bin system. There are ways systems to do it, where two containers of inventory reorder the first is emptied. The point would be symbolically represented as well, wherein or it could be a barcode where you walk into malls, you barcode it, and you get a hang about which product has gone, which is still lying. So the shelf life could, the shelf visual display could be arranged accordingly. Lead time. Lead time is the time interval between ordering and receiving the order. Holding cost, we have mentioned the cost to carry an item in inventory for the length of time, usually over the year. So holding cost also is how much of cost is incurred to keep the stock in place in the right state is important. Ordering cost of the ordering and the receiving inventory. So what kind of cost is involved in ordering? The shortage cost, wherein cost where demand exceeds supply. So where demand is bigger than the supply, of what is the shortage cost. And there are classification systems to classify different kind of, so we have tried to understand this calculus and models based on a very micro level, where only we are speaking of one particular product. But we spoke of the Home Depot example, 35,000 different types of SKUs, any product, even the raw materials, it touches on closely a lakh SKUs, either as raw materials, work in products, work in progress, or the finished goods. So the range is huge. So a classification helps to prioritize things. That means classifying inventory according to some measure of importance and allocating control efforts. A, important, B, moderately important, and C, least important. If you see in the graphical representation. So based on this differentialness also needs to be factored in based on the customer satisfaction. So if we have a product which is a flagship brand for the organization, key selling brand for the organization, the inventory equation changes there. Then a product which is on the decline, where the product life cycle itself, the product is on the decline, you really don't want to stack up volume. Equation, mathematical calculus changes for the graph because your demand deviations are less. Cycle counting. So when you speak of cycle counting, is the physical count of items in inventory, wherein cycle counting management defines as how much accuracy is needed. For example, for a niche kind of thing, we want a higher service level. For a product whose life cycle is on the downside, we don't want much accuracy. When should cycle counting be performed and who should do it? So it could be based on EOQ model, the order size that minimizes total annual cost, and economic production model or quantity discount model. So EOQ is one of the models that we spoke about. The others could be economic production control, where economies of scale comes into picture, or the quality discount model. So we want to look into not only the scale, but also what is the best quality that you can give at a larger proportion. Certain assumptions. Now, when we are speaking of EOQ model, the entire example of the car model was on EOQ or economic order quantity. But there are certain assumptions that we are making, and we need to be aware about what assumptions that we are making. Assumptions are only one product is involved. We spoke that we were seeing only with one product. Annual demand requirement is known. That means it doesn't change much is what we are assuming. Demand is even throughout the year, and lead time doesn't really vary much, and each order is received in a single delivery, and we know in reality or in practical terms it alters big time, and there are no quantity discounts. So these are a few assumptions that we make when we are speaking of EOQ. Let's also get to know a bit about what does economic production quantity mean. When we think of EPQ, it means that production done in batches or lots. Now, this is also important. What batches we are producing? Capacity to produce a part exceeds the part's usage or demand size. Assumptions of EPQ are similar to EOQ, except orders are received incrementally during the production. Now, batch sizes are important for production houses because scales are important. Economies of scales are important. That impacts cost. That also depends on customer needs in what batches. So that the batch size will depend on those factors as well, the demand. The assumptions are for EPQ, economic production quantity assumptions are only one item is involved again, actual demand is known, usage rate is constant, usage occurs continually, production rate is constant, and lead times does not vary. These are the similar assumptions that we made also in economic order quantity as well, and no quantity discounts as well. Let's look into the economic run size. When you look at economic run size, Q0 is equal to under root of 2ds into a divided by h into square root of p divided by p minus u. Let's look into the variables. Variables mean total cost. When we are looking at with purchase cost, it would be annual carrying cost, annual ordering cost plus purchase cost, and that would amount to total cost. We are seeing with production cost would be, we have on x-axis again quantity, y-axis cost. So we have a PD, production cost would be that point where the total cost is optimized based on quantity with the demand. That means that total cost with constant carrying cost. So we have to look into constant carrying cost with different variables A, B, C, decreasing price, and we have variables of OC and CC at different points, price of A, B and C. With this, what comes is the reorder point. So when the quantity on hand of an item drops to this amount, the item is reordered. Safety stock, we know that it is a stock that is held in excess of expected demand due to variable demand rate or actual lead time. So we spoke that safety stock we should keep with to accommodate fluctuations or variance in demand as well. Service level is the probability that demand will not exceed supply during lead time. So we don't want those conditions to happen as well. So the deterministic of reorder point would be number one, the rate of demand, the lead time, demand and or lead time variability, and the stock out risk as well, the safety stock. So if you are looking into the safety stock, we want some stock to exist where there would not be a stock out thing because demand is more than the supply. So safety stock reduces the risk of stock out during lead time. So we have a reorder point where the time when an order should be placed in, and also the ROP, the reorder point, is based on a normal distribution of lead time demand. There also could be placed in terms of fixed order interval method. That means orders are placed at fixed time intervals, order quantity for next interval. Suppliers might encourage fixed intervals because it gives a streamline and a process for them. The payment structures could be accommodated accordingly. May require only periodic checks of inventory levels and risk of stock out as well. Fill rate, the percentage of demand filled by the stock on hand. These are the variables through which the fixed order interval could be managed. And the benefits of fixed order are tight control of inventory items. Items in the same supplier may yield savings because ordering, packaging, shipping cost could be optimized as well. Even payment terms for that matter as well. May be practical when inventories cannot be closely monitored. In those cases, it really helps big time. But there are disadvantages as well, and disadvantages are requires a larger safety stock, increases carrying cost as well. Cost of periodic reviews as well goes up as far as disadvantages. Those are multiple points. Now we have a single period model as well. In the single period model, it goes on to apply and show and demonstrate what it happens. So in a single period model, what happens is, single period model is a model for ordering of perishable and other items with limited useful lives. So whenever we have products which are perishable, now what does perishable mean? Which get destroyed fast. The bread example that we spoke about, ice creams, all edible products in fact forms under perishable goods. Single ordering point helps a lot. Storage cost, generally the unrealized profits per unit. Storage cost. Excess cost is the difference between purchase cost and salvage value of items left over at the end of the period. So there is an excess cost as well. Single period model, if you see, there is a continuous stocking level wherein identifies optimal stocking levels. So the bread example that we spoke about, again a perishable good, everyday business changes, and hence a single period model helps a lot, where identified what is the optimum stock level. Optimum stocking level balances unit short and excess cost. It really makes a good trade-off. Discrete stocking levels as well, which means that service levels are discrete rather than continuous, and desired service level is equaled or excelled. Since you're going at a very micro level and the daily fluctuations of demand are factored in, you have a larger flexibility when it comes to inventory management and control. So optimum stocking level, if you're speaking of, and if you want to have a graphical representation of how it goes something like this. Service level is equal to CS divided by CS plus CE. CS is the shortage cost per unit. CE is the excess cost per unit. So if you map this out, so on x-axis we have quantity, and y-axis two things have an impact. One, the shortage cost and the excess cost. And you also need to have a service in portion. So the SO is the balancing point which balances and optimizes the shortage cost and the excess cost. And the entire premise of inventory management is that when you balance out the shortage cost and the excess cost. Let's take an example, last example to really sum up our model as well. So C is equal to 0.2 per unit, CS is equal to 0.6 per unit. Service levels are CS divided by CS plus CE we spoke about. So 0.6 divided by 0.6 plus 0.2, that really accounts to service level of 0.75. So with service level, now we are always referring to this, we are always giving service level as 75%. The quantity accounts to 1 minus 0.5 is equal to 0.25. So that means that the operational strategies that needs to function well are, it tends to hide problems. Easier to live with problems than to eliminate it, and costly to maintain. Now these are the few elements that we need to take care of when we are looking at how to bring things in operational when we are speaking from an inventory perspective. Great then. I mean, this was the end of the presentation for us for the day. Let's quickly recap what we have done. We have spoken about what is inventory management. We have defined it in terms of raw material cost, work in progress, and the finished product stock. We have spoken about different models, right from economic order quantity (EOQ). We have also speak of economic production quantity as well, which is one of the two that we apply, and we look into certain variables that are important in calculation. So we have looked into various calculation methods. We factor in inventory costs depend on demand, on lead time, on what quantities to be order how to factor in certain variations in demand as well. And we have gone through various calculus to understand this. So great then. So I hope this session was useful. My request would be go back to your written data as well, read them through, keep referring to this video as well.